Welcome to Train Signal. You're watching a video about network media. In this video, we're going to talk about wired media. Now, we learned in the last video that media is what we used to connect computers to each other in a network. We also learned that there's both wired media and then also wireless media. Well, in this video, we're going to talk about wired media or cabling. Now, we'll start off by looking at the three main types of cabling, which are twisted pair, coaxial, and fiber optic. After that, we'll talk about something called plenum grade cable, and we will answer the question, what the heck is the plenum? And I'll tell you what, that question has been asked just that way by many students over the years. So we will answer the question, what the heck is the plenum? Then we're going to go in and take a look at some of the common connectors that are used on these cables. We'll look at different wiring standards. We'll talk about LAN, which we learned in the last video is local area network, so LAN technology types. And then we'll see how to distribute our computers around the building, around the room, via wiring distribution. So first, let's take a look at our cabling, right? Our wired media. And the first one we want to take a look at is something called twisted pair. Now, twisted pair cable is divided into different categories. And you'll notice that up here, you'll see I have the word CAT. CAT is short for category. That's how we commonly refer to these cables. CAT 3, CAT 5, CAT 5E, and CAT 6. Let me get that line out of the way so you can read that. Those are the four most commonly used categories of twisted pair cable. But they're not the only categories. Now, CAT 3, you'll notice I have there, it says 10 Mbps. Now, that stands for megabits per second. And I will tell you that there's also an Mbps, which would stand for megabytes per second. But in that instance, the B would be capitalized. Okay, so when you see a lowercase b, that's megabits per second, or how many thousand bits per second. Now, category 3 goes a maximum of 10 megabits per second. That's the maximum throughput. So even that cable, I almost could have left off of this particular explanation, because in today's networks, 10 megabits just isn't going to cut it. I mean, we have high-speed internet connections, which would take us out of our local network. Even our internet connections will exceed 10 megabits per second these days. So realistically, the first grade of cable that you'll see out there today is Category 5. Category 5 can travel up to a maximum of 100 megabits per second, which is, well, we'll say, adequate for today's networks. You'll see a lot of networks today that still use not only Category 5 cable, but still use 100 megabit technology. But although you may see that in some networks, I would say that the majority of today's networks actually use Category 5E cable, and you'll see there that this Category 5E can go a maximum of 1,000 megabits per second, or what's commonly referred to as 1 gigabit per second, or a gigabit network would use Category 5E cabling. Now, besides Category 5E, you'll notice that we have here Category 6, which, well, it's listed the same. It's also used for gigabit networks. It's also for 1,000 megabits per second. The primary difference between 5E and 6 is 5E was designed, and I don't want to get too overly complicated here, but basically it uses the 100 megahertz range, whereas Category 6 uses the 200 megahertz range. And again, I don't want to get real overly technical and confuse you at this point, but I can tell you that Category 6 cable will be more commonly used going into the future, because although it's the same theoretical speed, you can realistically get higher actual speeds. I know that probably sounded confusing, but even though the maximum throughput is 1,000 megabits per second for both, it doesn't mean you're going to actually get 1,000, okay? Because there's interference and things like that that can have a lot of bearing on the actual throughput speed, and category 6 is not as susceptible to as much of the crosstalk and other types of interference that is out there. So realistically today, what's our number one type of cable that we're going to find out there? Category 5E, but we're going to quickly see that move into category 6 in the future on our gigabit networks. Now, the other thing I want to tell you about these categories before we go on is that the main difference as we go up through the categories, we'll say from 3 to 5 to 5E, the way we get the faster transmission is by twisting, right? We're called twisted pair cabling. By making more twists in the cables, by having them twisted more tightly, it has been found that data can travel faster. And just so you understand what we talk about when we say twisting, this right here is a picture of the inside, of what the inside of a twisted pair cable looks like. And you'll notice that right here, this is actually a pair of cables, and they are twisted around one another. And the reason they're twisted is because when you have two cables running in parallel with each other, well, then you tend to get what's called crosstalk, where you get signal bleed from one cable into the other, whereas when you twist them, that does not happen. Okay, so in a standard twisted pair cable, you'll see that there's 1, 2, 3, 4 pairs of cable for a total of 8 wires going through the cable. Don't worry about this item and this item. These are just extra fillers that go through the cable. They actually assist in the process of cutting into the cable and protecting the cable and terminating the cable, etc., etc. There are 8 wires in a twisted pair cable. Now, all of the different categories, so all twisted pair cabling, can travel up to 100 meters before suffering from something called attenuation. Attenuation is the deterioration of a signal over distance, and we could even say over distance and connections. The best way I like to describe it is if you were to stand, let's say, across a large room, a gymnasium, an auditorium from somebody else, right? You're on one side and you're on the other side. If you were to speak, let's say, in a normal voice, well, they may not hear you, right? Because the signal of your voice, the sound waves of your voice, are only going to travel so far before they start to deteriorate. They diminish. They diminish into silence. And so they don't hear you. Whereas if you're yelling, then they might hear you, because now you have given a stronger sound signal. And so that sound is going to travel a longer distance before suffering from that same attenuation. But even when you're yelling, your voice is only going to go so far, right? If you were, let's say, outside, you're not even in a room, you're outside. You yell as loud as you can, people are only going to be able to hear you a certain distance away. Well, that's attenuation. We have the same thing when sending an electrical signal over a copper wire, which is what twisted pair cable does use. It uses copper wire. Well, when that signal is sent out on the copper wire, twisted pair cabling will allow for up to 100 meters before you suffer from attenuation, meaning if a computer is more than 100 meters away from another computer, well, then it may never actually get the transmission because the signal will have deteriorated. Now, the next thing I want to talk to you about is the difference between something called unshielded twisted pair, or UTP, and shielded twisted pair, or STP. Unshielded twisted pair is susceptible to something called EMI, electromagnetic interference. If you were to run your cable through an area that has a high level of EMI, EMI is something that is given off by other electrical devices. If you were to run a cable, let's say along a generator, the generator is going to give off a lot of EMI. Something to be a little more common is, let's say you were running cables near fluorescent lighting. Fluorescent lights give off a lot of EMI. Well, that EMI is going to interfere with the signal on that cable. So when using unshielded twisted pair, you may actually have a problem if you are going to be in one of those areas. Now, this picture right here, the one that I circled before, this is an example of unshielded twisted pair. Whereas the picture below it, right down here, this is an example of something called shielded twisted pair. And it protects against EMI, and it's kind of hard to see, but if you look carefully, you will see that each of the twists have an extra layer of shielding around it. Okay, you can kind of see the difference right here in the cable. This is just bare wire exposed, and then right here is where you can see there's like a foil shield. And that foil shield, just so you know, is going to go all the way through the cable. This was just stripped off to show you that the wires are underneath these shields. Okay, so shielded twisted pair is used to protect against EMI. So if you have the need to run twisted pair cabling through an area that it has a high level of EMI, you're going to want to use shielded twisted pair. And the last little tidbit you need to know about twisted pair cabling is that it uses an RJ45 connector. And that's actually the picture we have up top here. This is what a typical twisted pair cable will look like on the end. It will have the RJ45 connector, and if that connector looks familiar to you, even if you haven't worked in computer networking, well, that might be because it looks just like a phone cable, right? Your telephone plugs into the wall using what's actually something called an RJ11 connector, which is a smaller version of the RJ45 connector. But we'll get into connectors in just a little bit. For right now, make a note, twisted pair cable uses an RJ45 connector. The next type of cable that I want to talk to you about is something called coaxial cable. Now, I will tell you before we even get into this that coaxial cable is pretty much a thing of the past. Okay, we don't see a whole lot of coaxial cable used in computer networking, and the reason why is, well, basically it was replaced by twisted pair, because twisted pair cabling, as you will see as we go through everything here, is, well, better. It's better, faster, easier to use, less expensive. So that's why coaxial cable really isn't used much anymore. But you need to know about this cable. Well, first of all, you should know a little bit of history. You should know how things were, not just how things are. But also, if you're planning on taking the Network Plus certification exam, you may get some questions about coaxial cable. Now, coaxial cable is made up of 4 layers. And in the drawing that I have right here, you'll see that we have a stripped down version of the coaxial cable. The first layer is the copper core. Okay, and that's this right here, this little wire. This is the center wire that the signal actually travels on. Okay, so that's the copper core where the actual electrical signal is sent. Outside of that, we have an inner insulator. Okay, so this is just a form of insulation that is used to separate the inner copper core with the shielding, or the wire mesh shielding. Okay, that's what we have right here, and this wire mesh shielding is used to help shield out crosstalk, EMI, things like that. Now, one of the things you may notice is that unlike twisted pair cabling, where we have the wires twisting around each other, we just have a single wire. And what that means is if we were to take 2 coaxial cables